All right. Hello, everybody, and welcome to the Astrobee Challenge with Jason and Anar. My name is David, and I'm going to be the host today for this webinar. So we'll be covering a few things today. So in a moment, I'll be introducing Jason Crusan, who would be talking us through an Astrobee overview, and then he'll discuss research context, as well as the context of the background and why he started this challenge. From there, Jason will also talk about his time at NASA. Then we'll turn things over to Anar, who will walk us through how to enter into the challenge. And then we'll end things off with a general Q&A. And this is your chance to ask Jason any question, either related to the challenge or not related to the challenge. So the floor will be open for that. Now, with the Q&A panel, you will find in Zoom a Q&A tool. So please use that tool to ask all your questions. We will not be addressing questions in the chat. We will only be addressing questions that are in the Q&A, that are asked in the Q&A panel. Okay, so make use of that. So with that being said, I would like to introduce Jason Crusan. So Jason has been previously with NASA for over 14 years, and though he's not with NASA right now, his most recent role within NASA was Director of Advanced Exploration Systems. So I'd like to welcome Jason onto the virtual stage. Jason, the floor is yours.
Oh, thank you, David. And good morning, good afternoon, and good evening to everyone signing in today. Thank you guys for taking the time out of your busy days to potentially take a look at the challenge we've been putting out there for the freelancer community. So maybe I'll step right in a little bit about the overview of the Astrobee Challenge series. So some of you may be familiar with the Challenge series. We've actually been running the Challenge series for a couple of years. A couple of years ago, we sought about and asked the freelancer community to design a robotic arm for the space station for a platform called Astrobee. And Astrobee is a free-flying robot that's at the time was proposed to be built for the space station, but is actually now built and flying around on the International Space Station. Its job is to go around in with a kind of mobile video camera and or a sensor payload package and be able to measure things on the inside of the space station, kind of a virtual crew member per se for the space station. At the time it was a proposed platform, and actually since then it's been built. When we had the freelancer community originally contribute to designing a robotic arm, and that robotic arm was useful in helping, basically allowing that free fly robot to grab onto a handrail and perch and potentially move the robot around back and forth and such. So we had all those solutions, and those were really, really great from the freelancer community. And so what we wanted to be able to do is we've been engaging in open innovation in NASA for many years, since when I was there, and then NASA still does a lot of open innovation challenges using the freelancer community and a couple other communities out there. And one of the key questions we always had on these types of engineering design challenges is not only can the community submit and actually solve the problem itself, but can the community actually help us understand all the various solutions and solutions. So the challenge that we're running right now is actually taking a look at all the solutions that were provided before and asking the community to take a look at those, help us judge things like novelty, the feasibility of that, or the overall quality of the submission, to better understand or winnow through like a large, so many times in open innovation, you could end up with thousands and thousands of potential solutions. And one of the barriers is actually evaluating all those, and using external evaluators would be very advantageous in order to speed up that evaluation, or at least kind of NASA point to the solutions that it probably should spend the most time for. So we designed this experiment series to take a look at how the crowd can help evaluate. And one of the key questions is actually, do people need expertise or not in doing that evaluation? One of the things we know is sometimes experts actually have a bias in their evaluation, and experts may not evaluate novelty in the way that needs to be done, and may only evaluate it in the way that of things that they've seen in the past. So actually, people's various backgrounds actually give you different views on novelty, may give you different views on feasibility, and different views on the overall quality. So what we've asked the community to do and participate in is helping us in that evaluation, helping us understand what backgrounds and what expertise levels are actually best at helping NASA and others figure out novelty, feasibility, and quality. So that's what we've done. We had a large number of freelancers register to potentially participate. And from that, we selected at random a set of folks that from the community that actually there's no screening beyond random selection to do that evaluation. Another set of selections, random selections, are people that likely have some robotics experience in their CVs. And then another set is we actually had a skills exam or test as part of the registration process. And even though somebody may not have the expertise, say in robotics background or specific academic education, they did pretty, or they didn't do really well on a skills set. That skills test gives us another way to look at it. So we have groups of people randomly selected to participate to do that evaluation in all three. And we're looking forward to getting a large number of the evaluations done. And that will help us understand and basically how we can use the crowd and how does expertise and background actually help or hurt evaluation. So that's what we're out there right now, and that's what we're trying to get participation. And I just wanted to thank those in the community that have actually already helped us with evaluation, and then just encourage those that have also been invited that haven't finished to take a look and spend some time with us on helping us understand this background. So I think with David, with that's a little bit about the overview of Astrobee, and a little bit about the research that we're looking at. We can move on to the next topic if that's okay, David.
Yeah, sounds good. So just a quick word from Anar in terms of specifically how to actually enter into the challenge. So I'm going to turn things over to Anar.
Hello, everybody. Many of you already know me. I'm a technical project manager with freelancer.com. I've been communicating with many of you on the platform. Before I explain how to proceed and how you, if you did not submit evaluation, how you can do so, David, could we please share the poll with them? I want to see how many of the people present today did not submit an evaluation. So if it's, guys, if you can do this, please take a minute to answer the question if you submitted evaluation or not. We're just curious to know what percentage of people didn't submit it yet.
All right, so just about, I think, almost everybody on the call today live has entered. So looks like most people have entered.
Okay, so we have only one person who didn't enter, and most people did. But I guess for people that will be watching the recording, I'll explain how the process works again. So many of you have been messaged and emailed the following link, which is a link that when followed, you would be presented with evaluation. If you don't have this link, feel free to contact Anar Tech Copilot. You already should have this username because I've been reaching out to every single one of you. So if you don't have this link again, make sure you reach out to Anar Tech Copilot. I will provide it to you. Ensure that you complete it. So don't quit halfway, otherwise you might not get paid. So make sure you go to the end. And when you will get to the end, there will be a completion page. When you get to the completion page, ensure you're taking a screenshot. Now, with regards to submitting the screenshot, it seems that there's a bit of confusion on that end with some people as well. So I will share my screen and quickly show you how you can submit the screenshot, right? So let's say you, this is one of the contests we're running multiple. If you don't know which one you're at, A, B, or C, simply message Anar Tech Copilot. I will send you the link. But as I said, many of you have already been provided this. The way you submit it, once you completed your evaluation and you got to the final page, you took a screenshot of completion page, you come here, and there's two ways you can submit, right? Number one is you click submit entry, right on the context, you click submit entry, enter your information, upload your screenshot. Make sure you upload your screenshot. If we don't get screenshots, we can't verify that you have actually completed the evaluation. So upload your screenshot. In terms of value, enter 25, same basically the value of the contest. So don't enter 0, don't enter 12 or any other values, because it creates problems with you getting awarded. It creates delays in that regard. And another way of doing it, for example, if you come here and you don't see submit my entry, simply go to entries and then you should be able to see this. That will be it for me. Are there any questions in regards to how to submit entries?
Perfect. Just on that note, if you have any questions as we go along, once again, feel free to pop those into the Q&A panel chat. And on that topic, we're actually going to enter into our Q&A. So starting with questions that focus on Jason's time at NASA, or maybe just space in general. I know I have a few questions about space that I would love to ask Jason. So maybe we'll start off with those. And then we also have some prepared Q&A items to share with you guys. So questions that we've collected ahead of time that you guys had. And so we will kick off with some of those as well. But first of all, just to make things a little bit interesting, Jason, I have a question for you. And the question is obviously about aliens. So I want to know your general thoughts on aliens. What do you think they might look like? I know they're out there. We've seen the UFO footages. So let's talk about aliens really quick.
No, thanks, David. Yeah, so for those of you guys don't realize, I spent almost 24 years actually at NASA before I left, and one of the things that we always were looking at is the search for life on other planets. It's actually the primary reason for the Mars missions is to actually understand past life on Mars. So the scientists theorized that basically Mars was very Earth-like at one point in time. And because it was very Earth-like, it likely had life. There's a lot of debate whether Mars still has life or not, but most of the scientists believe that the life is gone from Mars. But there should be evidence of life on Mars. There's lots of different theory that did life come to Earth via maybe asteroid impacts between Mars and meteorites coming back to Earth, or vice versa. And so there's been a search for that kind of existence of life on Mars for some time, and also following kind of the water to find where potential life could be. So I want for one keep on looking forward to the samples and how they keep on testing and trying to find where evidence of life was on Mars. Now, at the same time, you have other missions out there, and generically looking after what they call planet hunters, looking for planets around other stars that are very Earth-like. And what we thought was a potentially rare occurrence of an Earth-like planet around a star has now been proven to be completely incorrect, and meaning that there are now literally thousands of Earth-like planets that have been found around stars, most of them very, very distant from us. And my personal view on this is now that we know that there's at least thousands that we've found, and then if you look at how many stars and galaxies and such that are in the universe, it's probably statistically impossible for life not to exist somewhere. So, but we just haven't found it yet, or we haven't learned how to find it and what signals to look for. So I think at some point in time, yeah, we absolutely will find life somewhere. I don't think we've found it yet. So you see a lot of the videos and other things. I think there's a lot of other explanations for those today. But at some point in time, we're bound to find life somewhere. And will it be human-like, or will it be some other form of life? out there in the world and the universe. Yeah, I think it's statistically impossible for it not to occur somewhere. And I look forward to the days that we discover it. And maybe it'll open our eyes to our own reality of here. Hopefully they're not like us a little bit. That usually hasn't fared well for most of the world these days, but we'll see. But I think that'll fundamentally change our view on existence and everything if we find other life somewhere. So that's my view on it, David.
Awesome. Thank you so much. Anar, if you have any space questions, we have Jason here, so let him know. And for everybody else on this call, do let us know as well. I see the questions are coming in. So let's actually address some of those live questions. So starting here, so what do we plan to use for this system that we're developing? I guess he's referring to the research in the Astrobee.
Yeah, so the original Astrobee challenge was a small little arm to be attached to the robot. NASA did build an arm, and the Astrobee robots that are on board the space station actually have an arm on them now. And in fact, actually, just in the past couple of weeks, they've demonstrated the autonomous ability to perch, meaning the robot flies up, its robotic arm grasps onto a handrail or something solid, and perches like a bird would on, say, like resting. And so NASA did build an arm out of using some of the design inputs that came from our previous challenge, plus their own work internally. So that's going on as we speak. And then the data that will come from our actual experiments now, what this will help us for is every kind of challenge going forward, how do we do that evaluation task? Which is a pretty challenging one. And what we want to be able to learn is how can we use the crowd and freelancer community to potentially help with that evaluation. So out of this, we'll actually do some papers, and those will be openly published, and we can share those with you guys in the community as well, about kind of what are the best attributes to be looking for, and how do you use the crowd, or what segment of the crowd. My hypothesis behind the research is actually those that don't have skill in the area are likely probably better at evaluating novelty. And you actually want a diverse set of people to take a look at the solutions in order to really understand what you have. And if you only had experts, you're probably going to limit your view of that novelty or that feasibility. So that's the premise behind it. Yeah, we'll absolutely publish the results between ourselves and Harvard. Thank you for that one.
So a couple other questions regarding future rounds of collaboration and other projects like this in the future that everybody can participate in. Are there any plans to have future kind of projects like this?
Yeah, so NASA has a pipeline of projects that come through on a pretty regular basis beyond just the Astrobee challenge. So I would definitely encourage you to watch for those challenges. NASA is constantly publishing challenges on different platforms, and some of those are on Freelancer as well. So just watch that space related to the NASA account on Freelancer, and I'm sure you'll see some things coming through for people to participate in.
Awesome. We have a question about ongoing programs that international undergraduate students can participate in. So anything like that you're aware of?
I don't know specifically, but there are, NASA does have a couple different, one of the big challenges it has is called Break the Ice Challenge. And that one's actually not so much one that participates on a platform like Freelancer, but rather it engages universities and other organizations around the world to actually physically build an ice like drill, a drill to actually acquire ice and water from samples that would say from a planet. And that's actually open to teams around the world. And they can participate in that challenge and compete against each other at the university to university level. Yeah, there's a number of those kind of university engagement challenges that are out there, and Break the Ice is one of them. But if you look for that on NASA's website, you'll then also see probably some of the other university related ones, or ones that are appropriate for universities and or for small startup companies as well.
Awesome. So a couple more technical questions. So starting with this one, from all the evaluations I had to review, most people were trying to use Arduino. did you actually get a request for someone using space grade components in their submission?
Yeah, so some actually defined space grade electronics that could be. The ones when you do an evaluation, we're giving you a random set of 5 of the solutions, 2 sets of 5 for a total of 10 solutions to evaluate. Um, and some are actually involving the software side of it. Some are involving the hardware stack, like an Arduino board would be. And so some people suggested Arduino. Obviously, there's also space versions of that you can do as well. Ironically, some Arduino type boards have actually flown on the space station as well. So don't presume that just because it's an Arduino board, it means it can't fly in space. There was some work that we did years ago on a predecessor platform to Astrobee called Spheres. And Spheres actually flew with a basically commercial off-the-shelf camera that was basically a phone. And the interface between the phone and the Spheres was actually an Arduino board. And it flew on orbit, and it didn't actually have any issues. So take a look at that. I would imagine if you saw something in Arduino, you might have a perspective on whether it'll work or not. It might be something you would rate from a feasibility. And you might rate it high or low, depending on your own personal experience of how well that solution was. And there are other solutions that you might get. One of the challenges that you might end up randomly evaluating was actually just helping us pick the material, say for a robotic hand gripper, just the fingertip. And it all that one is literally picking a material with the right friction coefficient to allow it to hold on to objects. So the complexity or the technical knowledge does vary across the random ones that you're going to be asked to evaluate. But that's a really good question on the Arduinos.
Awesome. Let's move into some of the prepared questions. I know we had a couple of those, so great questions, and keep those questions coming in via the Q&A panel, please, guys. But let's hit up one of the prepared questions. So first question, will NASA provide participation certificates for this?
Yeah, so actually I was messaging back and forth with my ex-NASA colleagues just earlier this week. And yeah, we are going to be able to generate a participation certificate. We'll work with Freelancer on that, on how we actually get those distributed around the globe. It's likely to be a virtual certificate, but to enable that to be mailed easily or delivered easily to everybody around the world. But yeah, NASA will help us get some participation certificates out for all those that complete the task force.
Awesome. Next question we have, how does our input, so the freelancers input, contribute to the Astrobee project?
Yeah, so Astrobee is a research platform along with it is a robot that's flying around. It's intended to be up there for a long time. The payload bay on the Astrobee actually can be changed out. So even though there's a robotic arm up there that's actually attached to Astrobee today, we are looking at actually releasing a lot of the Astrobee designs that came from the previous work. And so this kind of goes back to the university question, is maybe some university students in the future could actually build a robotic arm, either based on some of the designs that were done before or their own design. And there are pathways to be able to test new payloads on board Astrobee. There is going to be a visiting scientist or visiting technologist kind of program for Astrobee. There'll be folks at NASA Ames that will be helping with that in the long term. But right now, really the contribution primarily for the evaluation we're here is actually just a lot broader than Astrobee. We're just using the Astrobee data to help us understand how the crowd and freelancer community can help in the future.
Awesome. And how do I know if I have the right skills for this? Am I qualified to be an evaluator?
Yeah, the key thing here is everyone is qualified to be an evaluator. I used a little bit in my intro, but we are looking for people with all different types and backgrounds. And some people were randomly selected because they've just randomly selected and your set of skills was just whatever it was. Some people we did purposely select based on your robotics background. And some people were selected based on how they performed in the skills test. And what we did there is we wanted to actually a wide distribution of capabilities and background. So there is no right or wrong answer for evaluation, nor is there any right or wrong background to be an evaluator. We just want to know about your background, and maybe somebody that's really great at art and has no engineering skills at all, but maybe you're the best person at helping us understand novelty, where a deep robotics expert may not be. And we really want that diversity of backgrounds in order to help us understand for future, how do we use people with different backgrounds to help with evaluation. So I just encourage you, do not think that your skills are the wrong type. Please just go help. And there's no wrong background.
Very in line with that, we had a question stating that, you know, at NASA you have top class scientists and engineers, and why do you still have to ask for freelancers ideas, freelancers who have no experience and knowledge about space? But you just pretty much answered that too.
Yeah, I mean, I think it's really important as famous as NASA is, there's a couple tens of thousands of people that work at NASA, but really space is something for a lot of people. And NASA's vision has always been to try to open up space for the betterment of society around the world. Everything from Earth science data to new platforms for technology research and such. So we want those diverse backgrounds, and there's actually quite a bit of research out there about subject matter expert bias. That's one of the key things that we're trying to understand a little bit better is subject matter experts and those at NASA may not actually be the best at picking the ideas. So in the past, we've always used expert evaluation panels, and we actually think that that may not be the right way to do it. And we want to see and take a look at a different approach.
Awesome. So also a similar realm of question. So how do I know if I have the right skills for this task? Am I qualified to be an evaluator?
Yeah, again, everybody's qualified to be an evaluator. The evaluation is set up to be pretty simplistic, meaning it's a 7-point scale for each of the novelties, feasibility, and quality. And then from your point of view and your background and experience, we ask you, why did you give it that score? So if you give it a score of 1, being not very novel at all, why would you consider it not novel? Is it something that you've seen before? Is it you just don't think it's that novel? Or vice versa? Why is it really, really novel to you? And it's your perspective that matters. There is no absolute right answer on that. So.
Awesome. And just talking through the specific evaluation, what does a good evaluation look like?
Yeah, so a good evaluation, again, it's a 7-point scale. And after each of the 7-point scales, there's a text box of giving your opinion. So a good evaluation is the numeric score that you give it, and a little bit about your description about why you gave it that score. And then we do ask about your confidence as well. So we ask about your score and then how confident you are in that score. And that there's no right or wrong answer, but just answering the questions and providing a little context in the text box is all that's really required. At the very end of the task, we do ask how you would define novelty, how you would define feasibility, and how you define quality. And all that does is give us a context for how you provided a frame of how you provided your answers. So a good evaluation is just completing that. You do it for 2 groups of 5, and then you'll be all set.
Perfect. So great question, great live questions coming in. So let's go back to one of the live ones. So what are the top priorities for the next 10 years at NASA? So I know you've left NASA, so you might not be able to answer this, but what do you know about the next 10 years for NASA?
So, I mean, one of the big priorities, and I worked in human spaceflight for the good part of my career at NASA. So maybe I can talk a little bit about the human space priorities. So NASA's been in low Earth orbit with the International Space Station for basically 2 decades. So there's priorities in different areas for the next step for NASA. For low Earth orbit, the International Space Station, what NASA wants to be able to do is how to switch from a government operated, NASA operated space station to how do you switch to commercial space stations? And basically that being operated on with many different providers. So there's over the next 10 years, you're going to see increasing numbers of private astronauts or those types of things. And then you'll actually see private space stations being built in addition to that. So they're under the way to do that. In fact, there's some private astronaut flights that have caught the news recently. And the first one all the way to the space station is scheduled here for later this year. And then NASA's already approved the first commercial modules to be added on to the space station. And those will form the basis of a new commercial space station eventually. So that's the low Earth orbit piece. The next piece for human spaceflight is sending people beyond low Earth orbit. So there's always been a big debate. Is the moon next or is Mars next? And the plan is the moon is next, but the moon is enabling Mars and Mars missions. So the next thing that's being built is an orbiting, what they call gateway around the moon. Think of that as like a dry dock, like a shipping dry dock, and a place where you park your spaceships whenever they're not being used. They're building that to be in orbit around the moon. And that is like a staging point where people and crews will come from Earth, they'll come to the gateway, they'll get in a lander vehicle and go to the surface of the moon, and then come back to the gateway after that mission is done, and then come back to Earth. Eventually, that same gateway is where you will stage rockets or spaceships to go to and from Mars from. So eventually, one of those missions, after they do the moon missions, now they'll launch a spaceship that'll attach to the gateway. Crew will get in it, and it will go off to Mars, conduct a Mars missions, come back, and instead of coming back all the way to Earth, it'll stay in space and then be reused for the next flight, just refueled and those types of things. And there's many different organizations that NASA's funding to help do that, from SpaceX, and you see the other private organizations like Blue Origin and all that competing as well for the lander. So at some point, there'll be a lander that NASA will help purchase basically, or enable to be built. And that lander will be what goes from the gateway down to the surface. And then hopefully then they'll move on to then doing the Mars mission. So I think over the next 10 years, you'll see humans back on the surface of Mars, surface of the moon. And then that kind of critical infrastructure getting ready for Mars missions after that. So I think it's an exciting time we have with kind of commercial space flight in suborbital, commercial space flight to low Earth orbit, and then basically humans returning to the moon. Many of us only read about that in the history books. I myself was not alive either when the Apollo missions were done. So it'll be kind of our generations and younger. It'll be the first time we've seen our colleagues on the surface of the moon live. So
Jason, on that topic, this is not one of the live questions, but on that topic, why is it so hard for us to get back to the moon? We've done it once before, right? Why has it taken this long to begin the conversation again, going back to the moon?
Yeah, it is very, very difficult technically to do it. So the simple analogy I use is if getting to space, if that energy was, say, 1, just normalizing it to a number, getting to the orbit of the moon is 10. Getting to the surface of the moon is 100. So these are what we would call gearing ratios. And so if you think getting to space is really hard, getting to low Earth orbit is really hard, it's 100 times harder to get to the surface of the moon and back. And because of that, it takes a lot of resources, a lot of technology, a lot of propellant to make that round trip. When the Apollo missions were done, I think it peaked out to be spending about 5% of GDP of the United States economy at the time. NASA is now 0.05%, or 1/2 of 1 cent, basically, of the United States budget and spending. And NASA still represents 50% of the world's spending on space combined. So it does take a lot of resources to do it. It is very technically hard. I think we basically lost the will as humankind to keep it up after Apollo. And now we're going back after recreating that capability to go land again. There's a lot of research doing to understand what the Apollo missions did and how they did it. And now what you're seeing is the modern versions of those to do it not just as a stunt, not just to plant a flag, but how do we do it to go back and potentially stay in deep space? I think they're on a good path, and they'll be doing that in the next decade. But then they'll also have a more sustainable way of doing it, meaning that hopefully we won't lose that ability again, and we can keep on being spacefaring people and exploring space.
That's amazing. So on the topic of the moon, what will be the effort to get to Mars? Is it similar to the moon, or is it 10x that?
So it is similar to energy wise. So when you have gone to the moon, you're basically halfway to anywhere in the solar system. So energy wise, or delta V, what they call it. So going to Mars, it doesn't require a lot of energy, but it requires a lot of time. So energy of getting there, you can trade time for that. So you can use less energy and you can get there slower, or more energy and get there faster. And with modern technology that we have today, the shortest version of that trip is about eight months to a year each way. And then the challenge of Mars is there are certain times of its cycle between Earth and Mars that it's closer, and certain times of the cycle that it's further apart. So Mars is an 8-month trip one way. Then if you want to be at Mars there, you can stay for a duration for a couple of weeks. And then you have to come home. Otherwise, you're staying at Mars for a year. Most of the NASA planning missions are a 1 year there, 1 year on the surface, and 1 year on the way back. So it's a 3-year round trip mission. So that long duration flight is actually the most challenging bit about it. The actual energy required can be done, but then it can be done today. But the challenge is, how do you keep a vehicle and humans safe for that 3-year round trip? Or do we wait for technology that has better engines for us to get there faster and shorten that trip down? So that's the trade that they make. Long duration, the biggest risk item in space is how long you stay in space. So that your chances of something bad going on is usually the biggest contributor of that is how long is the mission. So a 3-year mission adds a lot of risk to those folks that are going. The likelihood of like a medical event, even something like an appendicitis is a pretty routine thing that you can deal with pretty much anywhere in the world. An appendicitis on the way to Mars or back could be quite tragic for the crew. And so a pretty basic medical condition can get you in a lot of trouble. Yeah, that's a little bit more about how to get to Mars and what it takes to do that.
Amazing, thank you. Okay, so going back to some of the live questions and going back to specifically NASA Astrobee. So is Astrobee dedicated to the International Space Station only, or can it actually be taken into different roles in the near future, like the maintenance of space telescopes?
Yeah, so Astrobee is a bit of an experiment on what does a free flyer robot look like for many future NASA missions. Right now, it's a helper robot on board the space station, but we always envision that you're going to have helper robots helping on any mission. So the two different modalities, if you're not on a surface of a planet or the moon, is you want a free flying robot and or a robot that's probably fixed, where you can kind of a robotic arm that moves things around. So we envision that any of these kind of Mars missions or missions to the moon will have a series of robotic helper robots. And so Astrobee-like robots will be something that'll probably be on every mission going forward. There is actually it's also envisioned to potentially have an Astrobee type robot that can fly on the outside of a spaceship as well. So I talked about those long duration missions. So one of the things that we're always worried about is what happens if something strikes the outside of your spacecraft? How would you do a repair or even know that you had an impact? So free flying robots to do outside inspection are another use case. Astrobee itself will stay inside. The type of propulsion system it has, it's built for the inside of the space station, but it'll teach us a lot about free flight and 6 degrees of freedom flight in microgravity and be a great test bed. And it's actually the second or third in the series of free flying robots already. And I expect that there'll be many more in the future.
And how has the research process changed at NASA, if at all, based on the recent rise of the private commercial space research like SpaceX and what we're talking about before? Yeah.
Yeah, so NASA made a conscious choice several years ago to engage with the commercial sector to actually come up with new capabilities. So things like commercial cargo, which SpaceX provides, along with another company, Northrop Grumman. They provide commercial services of delivering cargo to the space station. And then that was extended to SpaceX and Boeing doing commercial crew, which SpaceX has demonstrated now, and Boeing hopefully will soon. And part of that was that NASA didn't want to own these capabilities by themselves. They wanted that to exist in the commercial sector. It's not like the government's own airplane services or commercial airliners. So the same kind of idea is, why can't the industry actually own those platforms and eventually not just fly government astronauts, but any astronaut? So I think that's been a very, very big shift. And you see also the acceleration of capabilities that the private sector has been able to add to that, with SpaceX's advances coming very, very quickly. But they get quite a bit of money from the government, from NASA, to help with that acceleration. So it's actually a better use of the taxpayer dollars in most cases as well, because they're putting their own money in. The NASA, the government, is putting money in. And instead of just $1 going after something, you get many dollars actually advancing that. And they also have a lot more flexibility than NASA in the pace of development. So I think it's been a very, very sizable change, and we're all kind of watching it in front of our eyes right now. So.
Awesome. And what are your thoughts on the Voyager station aiming to be opened by 2027? Do you think a goal like that is achievable?
An orbiting space station by 2027. I missed, David, what was the name of it?
Sorry, the Voyager.
Okay.
Voyager station.
Yeah, there's many different people that have actually proposed a space station in orbit around Earth. I think by 2027, yes, there will be commercial space stations. Which ones is a pretty big question. There's a company called Axiom that actually has the rights to put the extra modules on board the space station. So they are progressing their designs as we speak, and they will be launching modules here in the next couple of years. And they're actually launching their first commercial astronauts to the space station ahead of that as well. So yeah, so I don't know if I bet on any one of them winning, but I would bet on one of them winning at least by 2027 and getting something up there flying, and which will be exciting to see, kind of the first space station, the first commercial destination for all these crew flights and such to be going to.
So a couple more questions about Mars. So first question is, how long would you survive with deposits of water on Mars? And in line with that, which ones are the major issues about going to Mars besides water? And have we got a plan for it? Like, is there, yeah.
Yeah, so NASA's always anticipated that they'll be able to use the water that is on Mars to help keep people alive. That water can be used for many different things, drinking water, obviously, but that water also can be a source of how to make rocket propellant, either from the hydrogen there or the oxygen as the oxidizer. So one of the main ways to make rocket engines is hydrogen and oxygen. So you get, those are the building blocks from water. So NASA's always planned on using and creating oxidizer and hydrogen from the surface, from the water that's on the surface. And you actually create that using electrolysis, much like the world is trying to look at making hydrogen here for mobility and transport around the world. Water is absolutely critical. Some of the water is very challenging on Mars to get to, but NASA keeps on discovering more and more knowledge about the water and the water cycle there. Other big challenges on Mars is actually that duration, the time duration that's there. There's a bit of a challenge related to the exposure of radiation, but a 3-year trip isn't a lethal kind of radiation event. You can shield the spacecraft to minimize its radiation. When you get to the surface of Mars, you can use the water, and actually the surface regolith to actually shield yourself from radiation as well. So that's not a big challenge. And then the last big thing is really about the reliability of all the systems, the life support systems, and then you are landing on another planet, and you are going to have to take off from that other planet without really direct communications back to Earth while you're doing that. So think about the rocket launches you see on Earth today to launch humans into space. One of those occurring on the surface of Mars, but without the ability for that rocket to talk real time back to Earth, because you're at 40 minutes is your round trip communications to Mars, 20 minutes each way. So by the time a signal has gotten back to Earth and then back to Mars, the rocket's already taken off and it's either worked or not. So that time delay. So reliability, water, radiation shielding, those are kind of the big items for that you would worry about on a Mars mission.
Awesome. So there's a bit of a debate in the chat with regards to, is Astrobee cuter or is Wally cuter? And on that note, there's a question here that says, does NASA benefit somehow or get ideas from like science fiction movies, games, movies?
Yeah, so when I was at NASA, I actually got the chance to go to Comic-Con a few times, and this was always a question: who leads the innovation? Is it do the ideas come from NASA or space exploration, or do the ideas come from sci-fi? And it's hard to actually figure out which comes up with it first sometimes. And I think there's a lot of very big sci-fi and a lot of other just fans of kind of what the future should be. So they get inspiration from everywhere. And things like, even like Wally and others, they inspire the design of things. Astrobee was, the Astrobee robots were actually designed, and there was a lot of thought put into how does a robot that works closely with humans communicate to humans without like speaking to it. So Astrobee has a series of lights on it. Those lights are kind of indicators of where it intends to fly next. It has a little face on it, obviously, and so it can communicate. So you think about how do humans communicate emotions or intention of what you're going to do next. When you're walking down the street and you navigate, we don't think about how to walk around each other. We look for visual cues from each other to avoid each other. So what does a robot do for visual cues so it avoids an astronaut, or the astronaut can avoid it? So there's quite a bit of thought that goes into that kind of user experience, or human factors is the area of research for it. Good robots and good robot design kind of takes into some of those effects and tries to incorporate that to make robots kind of better to work with humans on a day-to-day basis.
Okay, great. And going back to some prepared questions. So where can somebody learn about the requirements of getting into NASA?
Yeah, so this is a question that comes up fairly often. So now you used to have to be basically be a US citizen, and that was your entry into being able to work for NASA. That still is a pretty big restriction, but luckily now, because you have all these commercial entities like SpaceX and others, now working in the space industry is much more universal around the world. There are, obviously you have to have rights to work in the country of whatever company that's there, but pretty much every country in the world has an emerging space program and space industry, and there's ways to participate in that beyond just going to NASA. I'm actually sitting in Australia right now. That's where I live, in Perth, Australia, on the west coast of Australia. And only recently, a couple of years ago, did they just form a space agency. And I remember years ago traveling to Australia, and people asked, how do I, as an Australian, get involved with NASA? And I said, please don't, actually. Go get the Australian space industry going. Make it happen here as well. And then as a global society, we all contribute to the vision of space. And whether you're in Australia, in the US, and India, wherever in the world, you see now many different groups now forming their own space industry, space agencies. And you can participate in space, not just by going to NASA, but actually where you live in the country you're in. I think that's the better advice. Now, if you want to go to NASA, there are pathways to do that. but it usually gets into the how do you get the visas and get the right to work in that country, much like our right to work challenges that are around the world. So
Awesome. So we have 6 minutes left. So guys, get your questions in. Jason, how are you for time? Are you able to go over a little bit?
I'll be able to go over a little bit, but yeah.
Okay, sounds good. So let's get the next question up here. So how do you nurture creativity and innovation within the organization? Do you outsource creativity or is it typically all done in-house?
Yeah, so NASA embarked on open innovation as an effort to actually pull in ideas from outside of the organization. So I'm a big fan of open innovation. Even my current organization I work with, we're actually running challenges and such as well. And no organization has everything you ever want or whatever you need. Bill Joy, who was one of the founders of Sun Microsystems, said, well, the smartest people in the world work for someone else. And there's also some work Eric von Hippel wrote. He wrote a book series called Democratizing of Innovation. And it was, knowledge is very sticky. It exists where it exists, and it's hard to bring knowledge into an organization. So then how do you actually go to where those that have expertise and creativity are already? So I think every organization needs to learn how to engage strongly across its internal workforce and partnerships, but actually how to reach outside of its organization to solve problems as well. So open platforms like Freelancer allow an engagement method to get to a very wide and diverse set of solution providers. And I think that's going to start changing the way we all work and create and invent, where everybody in the world starts contributing to solving problems, basically by the click of a mouse these days, and be able to do that and harness that expertise, because otherwise you're really limiting your organization if you're just doing it in-house.
Awesome. And how does NASA maintain its efficiency in terms of resources, environment, and time? What problems can or do occur in managing it?
Yeah, so efficiency is always a challenging thing for any organization. Whenever you're doing large, complex programs like building spaceships and such, doing that in an efficient manner is challenging because it's technically challenging to do that as well. And so a lot of times you look at the study of systems engineering as one way to look at this. So when you take complex systems, you subdivide the problem or decompose the problem in a way that smaller teams can solve each individual part of that. The challenge with that is that may actually increase efficiency, but then you're only working out a portion of the problem if you're on one team. And that may actually limit creativity or innovation. So there's always this balance of efficiency can actually impact creativity and innovation, but then you can't always be completely open and let everybody work on every part of the problem, or you'll never actually get it done. So this is a ripe area for research and experimentation. And I would say even after over 20 some years, 25 years of doing engineering, design and such, I don't know the answer to that question. We try to do it as best as we can and get the most efficiency, but caution yourself that efficiency actually can cause innovation to decrease. So that's the challenge NASA has, but everybody else has as well.
Awesome. So live question here. There is the notion of sending data centers into space, so cloud in space. What is your opinion on that? Is NASA doing something in that realm?
Yeah, so actually NASA has been looking at how to do edge compute basically in space, high performance computing in space. In the past, most of the data processing for spacecraft had to be done on the spacecraft in order to minimize the amount of data coming back to Earth. With the advent of more and more capable communication systems, both radio frequency ones and laser communications, the bandwidth to space is increasing. So if you have a laser communication system, say in low Earth orbit, that connection can be 10 gigabits per second to back to Earth. So now you're thinking about, can you use actually Earth-based cloud compute, and or can you do edge compute? And much like cloud architecture today, where you have cloud, you might have edge compute, and where does your high performance compute sit? Does it sit in the cloud? Does it sit on the edge, or is it actually shared between the two? Many of those different modalities are being thought of now because communication links are so much better than they used to be. And then it comes down to how much power you need to power that compute. And that's still a challenge in space. Power is still a pretty precious resource. If you're into the low digit megawatts on a spacecraft, you're pretty okay. But even that's quite large of a data load. So really it's going to come down to how much power you have. And then if there's communication links, maybe you can do the compute somewhere else. But I would say sitting in Perth, Australia, I would like to have a gigabit link to my house, and I can't even get that here. So, I think the space side is doing a little bit better than even some of our Earth-based communication links. But I think there will be a version of cloud operating in space and or edge, and you'll see basically our networks extending into space. Just like they've been extending around the globe on Earth.
Awesome. Last question here. Is there a role in artificial intelligence in Astrobee?
So Astrobee doesn't per se have artificial intelligence. It has autonomy and the ability for autonomous flight and autonomous manipulation and grasping and such like that. Depends on where you draw the line on AI. It's definitely high level autonomous, but it does have a compute platform on it as well. And I was going back before when I said Astrobee can be used by visiting scientists or visiting researchers. If there's folks that want to actually test AI algorithms on Astrobee, I expect that will be happening as that platform comes up and is made available. People will write different software on it and test it and see how Astrobee performs with the updates and software. So I would imagine it will be upgraded to have some capabilities in AI, and some of that will be focused on more and more autonomous free flight. It does have free reign of the entire space station, meaning it can fly around nearly everywhere on the US segment side of it, and then it has an ability to go back and autonomously dock and charge itself. It does have the ability to be commanded to say, undock, fly over there and perch and make sure a camera is pointing at whatever. That's what its first kind of use cases were, is kind of a mobile camera platform.
Awesome. And if somebody watching or watching the recording, their solution is chosen by NASA to implement, would that be shared with everybody, and that specific solution and the details of that solution, will that be shared with everybody?
Yeah, so in this case, we're actually not picking something to be implemented. We're using the crowd to help us do evaluation. But in other instances of NASA challenges, ones are picked and people are told what is picked. In this case, this challenge isn't about that, but we'll definitely publish the results about evaluation and how the crowd can help us with evaluation. Those papers will come out and they'll be put into normal peer-reviewed journals and those types of things, but freely accessible to be downloaded and read in the future.
Okay, awesome. Well, thank you so much, Jason, for your time. Guys, this call is recorded. This webinar is recorded, and the recording will be sent out to everybody who is registered. So feel free to go back and watch it to review any of the details and the questions that were answered. But once again, thank you so much, Jason, for your time and for all the information.
No, I really want to thank the community and you guys spending your time out of your day today, and then your time of actually helping with the evaluation experiment. It really is important to us, and Freelancer's got a great community and a great contributors around the globe. And just thank you again for all your time and effort that you put into every NASA challenge.
Perfect. We'll end on that. Thank you, everybody.
Thanks, everyone.
Thank you, everyone. Have a good one.